Hey everyone, welcome to our Portworx monthly demo. Thanks for joining us. We're going to get started here in just a couple of minutes, so just hold tight while folks join. Hey Bobbin. Hey, can you say something again, Bobbin? I couldn't hear you.
Hey, sorry, I was on mute.
No worries. All right, well, we have an exciting demo for you today on our autopilot capabilities. So what we're going to do when we do get started is I'm just going to kind of lay the foundation. If this is your first demo, monthly demo, then what you'll find is that we kind of introduce the topic, talk a little bit about the capabilities, and kind of just make sure that you really understand kind of Portworx overall. Then we go over to the bulk of our time, which is a demo. And so today, Bobbin has a bunch of cool things to show with Portworx Autopilot. And now you can bring automation not only to your applications, but also to your data using Portworx. So I'm going to go ahead and share my screen. Oops, not the right one. Show. There we go. Can you, yeah, you can see my screen. I can see it myself. And go into present mode. All right. Well, folks are still joining, but let's go ahead and get started because I don't want to give Bobbin short shrift on the demo portion. I like to start these by giving you just a little bit of background, just to make sure that you know you're in the right room and in the right webinar. And chances are, if you're here, you understand that business is key to data. Excuse me, is key to competitiveness. And really the success of business in general. Now, that's kind of it's almost a platitude. It is so obvious to all of us who work in this industry. What's not obvious is, well, how do you actually, do something about that insight, right? If we know that data is important to our business, then what tools and processes and infrastructure can we put in place to get the most out of that data? And a consensus has emerged that the best way to take advantage of what we might call the app economy is with a new stack of cloud native technologies that are built around things like containers and Kubernetes, but that also include kind of new people and processes like DevOps and what we're going to talk about a lot today, GitOps, in order to quickly be able to roll out new versions of our applications so that we can meet user demands. Again, if you're here, then it's really clear that this is not just a one-off, that this really is what we might call a mega trend within both enterprise IT as well as in kind of product development. Most new applications are being developed in containers. Apps that are running in Kubernetes are largely in production now. And those applications are running across multiple clouds. And all of that is well and good, except when we get to the question of data, which is how do we actually operate our data services in a way that's completely automated, that ties into our modern DevOps practices like CI/CD, like version control. How do we actually do that? Because as great as containers and Kubernetes are, they don't solve the data problems associated with modern applications. I'm talking about data mobility, data security, data protection, and more. That's what Portworx does. So we deliver a modern data experience that cloud native applications require that don't make you choose between performance and security and availability and data protection and things like automation and ease of use and self-service. We give you both of those together as part of a single platform. If you're just learning about Portworx, we are the leader in this space. So we've been recognized in a couple of analyst reports that came out recently from GigaOM, one on the overall Kubernetes storage market and another on the Kubernetes data protection market. Our customers are some of the largest, most sophisticated users of Kubernetes in the world. And the reason I show this slide is simply to say, if you have a problem, we've already solved it for another customer, and we can use that expertise and those insights on your application to help you avoid any potential pitfalls that can come along as you move on your container journey. The way that we do all of this is with the Portworx Kubernetes Data Services platform. In a nutshell, it's a single platform for any stateful application in any environment. Our customers are building large-scale Kubernetes platforms, and so they don't just run one database, right? We're moving away from everything's in Oracle, everything's in SQL Server, everything's in SAP. Now, a typical enterprise environment might run a dozen different data services, each backing one or more microservices. And so we need to be able to operate all of those data services consistently without necessarily being operational experts in each. And our customers use all of the major Kubernetes distributions. Many times they use more than one distribution, as they perhaps are running OpenShift on premises, but they're using GKE or Amazon EKS in the cloud. And to that point, our customers run across all of those infrastructures in the public cloud, in their own data center backed by enterprise arrays like Pure Flash Array, but also on bare metal servers. And we even have customers that run us on non-pure hardware as well. Portworx is 100% software layer, and we fit into all of those environments. It almost goes without saying at this point that we support our customers at every stage of the application development lifecycle. So our platform is composed of 6 main modules, and the focus of today's presentation is PX-Autopilot. So we're going to talk a lot about how do we actually automate the storage layer so that you can handle day 2 operations as they come up within your environment without relying on PagerDuty alerts and tickets and things like that. We want to integrate directly into your GitOps workflows. But Portworx is more than just PX-Autopilot. We have a container granular storage layer called PX Store that provides container granular volumes, provides replication for high availability, provides snapshots. We can extend those snapshots with additional layers of data protection using our PX Backup product or our PXDR product. The difference there being, what is the RPO and the RTO that you have for your application, and let us bring to bear the best solution to meet those requirements, regardless of your network architecture. PX Migrate is all about moving applications, including application configuration and data between different environments. And then PX Secure rounds it all out with container granular encryption and role-based access controls for all of your Kubernetes applications. So let's look at a couple of slides on PX-Autopilot, and then I'm going to talk about turn it over to Bhavin. So before getting into the how-to, I want to just make sure that we understand, where are we going with all of this? Automation is really valuable in and of itself, but what's the business impact of that? Well, one way to talk through it is to look at what one of our customers is doing. So Audi Business Innovation was, on their own cloud native journey, and they were running in AWS. And liked what the cloud provided in terms of agility, in terms of ease of use. They liked the business model, but they had 2 problems. So one was they had their CI/CD systems needed what we would call a shared a read-write mini volume, meaning they needed to have multiple containers access the same volume at the same time. Now in Amazon, there are a number of different ways to solve this. One is using Amazon EFS, which they found to not be as performant as they needed for their Jenkins workloads, and it tended to be more expensive than an equivalent solution running on Amazon EBS. At the same time, Amazon EBS wasn't a good fit because of the way in which they had to provision kind of at max capacity versus at minimum capacity to avoid having to take their application offline when they needed to scale their storage. Portworx solved this for Audi by introducing PX Store and PX-Autopilot. So PX Store took their underlying Amazon EBS storage and virtualized it into container granular volumes that can be mounted to multiple containers at the same time, right? Giving us a read-write mini volume. They could choose their class of EBS storage, including dedicated IOPS, giving them ultra-fast performance that exceeded what they were able to get with Amazon EFS. And with PX-Autopilot, they were able to under-provision the storage for each of those services, meaning that they only provisioned additional storage if they were actually consuming it. And at the end of the day, they were able to save 60% on their AWS storage bill as a result of the Portworx solution. So how do we do this? Well, the topic of today's demo is PX-Autopilot. So here I'm showing an OpenShift cluster, but this could be any Kubernetes cluster, where essentially what we're going to do is we are going to collect metrics about your applications running on Kubernetes. And we are going to have a series of policies that can be applied based on the rules that we associate with those metrics. So for instance, if I have a PVC that has 100 gigabytes of storage capacity, and my monitoring tells me that I'm at 80% capacity, well, I could have a policy that says if I'm 80% provisioned, then I need to increase my storage by 50 gigabytes or by 20%. And the actual, what the policy is configurable. We can also do that. So that's an example of a volume resize, which is actually that container granular volume. But we can actually also scale your storage cluster overall. So imagine in this example that, you know, I'm at 80 gigabytes consumed on this volume, but I don't actually have any additional storage capacity on my EBS volume itself. Well, what Portworx can do is we can actually add an EBS volume or resize an EBS volume so that you have enough capacity in order to resize your volume to begin with. One of the things that we're going to show today is how those policies can kick off a GitHub pull request or a pull request into whatever version control system you're using, so that an admin can approve that volume resize or that cluster resize before PX-Autopilot automatically scales your storage. Number 3 is not a necessary step, but it's one that we see a lot of our customers like when they think about, okay, Kubernetes is declarative. I want to make sure that my configuration is always checked into version control and that whatever's running in production is consistent with what I have in version control. And our GitOps workflow enables you to do that. But PX-Autopilot is really about monitoring your cluster. It's about applying applying policies, potentially approving those through various GitOps work methods, and then acting on those all in an automated manner. Here's an example of an Autopilot rule. If any PVC matches some given label and it exceeds X percentage of usage, then expand it by Y. And again, we can do this both for the PVC itself as well as for the cluster storage overall. And PX-Autopilot can also rebalance your storage cluster across different storage classes. And this becomes really important as you think about how does your environment age over time as Kubernetes reschedules workloads. you wanted me to make sure that not only are you able to meet the requirements of the application on day 1, but also on day 2, 3, 4, etc. So enough talking. I'm actually going to turn it over to Bhavin to walk us through a demo of all of this. And as Bhavin takes the reins, I will just remind everybody to put in questions into the chat. We want to make this as interactive as possible. So Bhavin will do the demo, but then we'll also answer questions at the end of the webinar. So with that, Bhavin, over to you.
Awesome. Thank you so much, Michael. Hopefully everyone can see my screen now.
I can't see it yet. Do you have to make your presenter? No, I don't think so. Yeah, I can't see your screen yet. Oh yeah, I can. Sorry, I was in present mode, so that's my fault.
Okay.
Yeah.
Got it. Perfect. So as Michael already walked us through around what PX-Autopilot is and how it helps applications consume storage without the need for additional admin intervention. If people are familiar with how we did things when we were dealing with virtual machines, if my VM storage or VM disks are getting full, I might need to open up a ticket through ServiceNow or any other ticketing system and request the storage admin to add more capacity to the underlying LUN or add more or expand my virtual disk. With Kubernetes, the problems still remain the same, and that's what we want to highlight, like how we can use PX-Autopilot to help you relieve some of those issues. So as part of the demo, we have a few use cases that we want to cover. One is definitely the GitOps workflow that Michael highlighted in one of his slides. But then we also want to show you, like without GitOps, right? If as an admin, I have already set all the policies that I want, and I don't want any manual intervention in the entire workflow. So if something gets triggered, or if the PVC reaches that 80% capacity at like 2 a.m. in the night, I don't have to go log into GitHub and approve that PR, and it should automatically add more storage capacity. We'll talk about that use case as well. So we'll focus on those 2 use cases in this demo. For that, today we have a Kubernetes cluster running in Google Cloud. So we have a GKE cluster, as Michael already highlighted, like we can work with any Kubernetes distribution. In the slide, we spoke about OpenShift. Audi was using AWS EKS, so I thought, okay, we'll mix it up and we'll do it on GKE just to show the breadth of coverage that we have. So as you can see, we have a basic 3-node cluster as part of this demo, which is running version 1.19, and we already have Portworx and PX-Autopilot installed on this cluster. So if I do a get pods in the kube system namespace, you will see that we have our Portworx pod, our store utility, which is our storage orchestrator for Kubernetes. Everything is up and running, and I set this cluster up yesterday, so everything was ready for this demonstrations. And kubectl, in addition to Portworx and Kubernetes, we also have monitoring. So we have Prometheus and Grafana running in the system. So Prometheus, we definitely needed to capture the metrics and trigger those autopilot rules. But we also have Grafana to include like a UI element for this, for the purposes of this demo. So let me, I'm hoping this is like readable to everyone. It's not too zoomed out or not too zoomed in. Let's do this. Let's exec into one of the Portworx pods and look at the storage capacity. So we did kubectl exec, and then we'll just use the PXCDL utility to look at the status. So all 3 nodes that were part of the GKE cluster are also running Portworx, and they have individual Google PDs as, attached to them. Each PD is 150 gig in size, and then Portworx or PX store, as Michael highlighted, basically aggregates all of this into a single storage pool that is then made consumable for your containerized applications. So everything is up and running and it looks good. So let's go back and let's start deploying some applications, and then we look at the pools. So if we look at an autopilot rule, this is where admins can specify all the conditions. So if you remember Michael's slide, or if you have used if this then that, basically it matches, it looks for your application labels, and it also looks for your namespace labels. So you can have either or. So you can basically attach this rule for any PVCs that are spun up in a specific namespace or with a specific label, or you can have a combination of both as well. Here, in terms of the expressions or the equation we have, we basically calculate the used capacity. So we calculate a percentage, and then we use an operator like greater than, less than. So these three lines basically means that if the PVC that's being monitored by this autopilot rule goes above 15% of its usable capacity, then take the following actions. And the actions are scale percentage. So basically add 100% more capacity. So double the size of my volume. Again, this is completely admin configurable. But then we also wanted to place a check in place. Like, we don't want the application to go crazy and just keep adding or doubling the storage that's available to the application. So you can also specify things like, okay, what's the maximum storage capacity that it can consume before an admin needs to come in and change things up. You don't want terabytes and petabytes of storage being consumed by a single application. That's gone haywire. And then we can configure additional things in terms of poll interval and cooldown period. So like, if this rule is triggered once, how long should it wait before it should act on a second trigger? So since we want to do this just for a demo purposes and be really quick about it, right now it's set to 10 seconds. But again, you can change this based on whatever SLAs or whatever requirements you have in your own organization. So let's do this. Let's get started. We'll apply this autopilot rule against our cluster. And then we have a simple Postgres app with a pgbench sidecar container to that application, which will basically write data to our Postgres database. So for the purposes of this demo, we have a few namespaces defined. So we have an auto namespace, which is where everything is automated. Portworx or PX-Autopilot will automatically scale the underlying volume. And then we have a ticketing system. Again, if we have time, we'll look at it, but it just means that we don't have any autopilot rule against it. So my volume will just become full and it won't do anything, and my application will go offline. And then we have a third one called GitOps. This is where we'll demo GitOps workflow. So let's deploy our Postgres database, and then we'll deploy it in the auto and the tickets namespace. In addition to the volume, and again, we look at the individual YAML files. I just want to get the data ingestion going before we look at the individual YAML files. kubectl apply if we deploy the app now. So we'll deploy the app again in both the namespaces. And then if we do a get PVC for each of these, you can see we have two PVCs deployed for the Postgres database. We have the actual data volume, which is 30 gigs in size to begin with. And then we have just the state volume, which is a really small volume to maintain state. Similarly, we have deployed the same thing in the tickets namespace as well. And then if you look at the pods, you can see that we have a pgbench a pod with 2 containers running in it. And then we look at the logs and see how it's trying to fill up our Postgres database. While we wait for it, let's look at the Postgres volumes. So again, as we saw, we are deploying 2 of these, 30 gig and 1 gig in size, just to maintain state and the actual data. These are simple read-write once volume that are deployed against a storage class that we have created just for this demo, which is a Portworx backed storage class. Let's go to the application YAML file and see. So we have a simple deployment with 1 replica and then 2 containers in each pod. So we have our Postgres container, and then we have a pgbench container, which is basically writing data into the database. Here we have provided a size of 30 gigs. So we deployed a volume of that was 30 gigs in size. We want to completely fill it up and see if the autopilot rule gets triggered at the 15% mark that we set using our autopilot rule. So now that we have looked at all the YAML files, let's look at our pgbench sidecar container and see how that's doing. So I'll just do logs, and then for the specific namespace, and we'll select the sidecar container, not the Postgres one. So as you can see, we wanted it to fill up 30 gigs of data. Right now it's close to around 3 gigs, so it hasn't reached a point where it will trigger the Autopilot expansion. In addition to this, like monitoring this, we can also look at a different command that we have, where we'll monitor the events for our Autopilot rule, which is of the name volume resize. So if I do that, I see that, okay, just a couple of minutes back, it recognized, or it identified a new persistent volume that was deployed with the correct labels, so that PX-Autopilot can pick it up and act against it. So right now it's in normal state because we haven't crossed the threshold yet, but we'll come back and keep monitoring this just to make sure that everything looks good. So let's switch to our Grafana dashboard. As we said, like Prometheus is not only supplementing our PX-Autopilot, but also providing some graphs for us to look at. Let me go back to the CLI and get the ID for the PVC. So CDL. Okay, so ending with 215A1. Let me refresh this. Okay, let's look at our data source and make sure everything looks good. So it's pointing at our Prometheus instance. If I do a save and test, okay, data source is working. Let's go back to the dashboard. Oh, while we are here, we can look at the Portworx cluster dashboard. So again, it's a 3-node cluster. We have a healthy quorum. All the 3 nodes are online. Everything looks good. It shows us the used capacity. So we had an aggregated capacity of 450 gigs across 3 nodes. So out of that, 47 gig is used. We are at 31% cluster utilization from a CPU perspective as well. If you look at other dashboards, we have a node dashboard as well. So you can select the node that you want and look at different metrics like disk usage, node CPU usage, memory usage. All of that can be monitored through a user interface. Let's go back to the volume dashboard, and okay, we have all kinds of PVCs now. 215A1, okay, right here. So this is the volume that we want to monitor, and not last 3 hours, just last 5 minutes. And 215A1. Oh, I have 2 selected. Okay, perfect. So right now we have a 30 gig persistent volume, and 4 gig of it is utilized. So again, 15% is just 4.5 gig. So the next time when the Prometheus scrap interval gets active, it will look at the increased size and then hit our trigger, or trigger event will happen for our Autopilot rule. While we wait, let's also get the GitOps application up and running. So here we have a similar Autopilot rule. And again, we have gone through the pre-work of connecting a GitHub repo and capturing a new personal access token, storing it as a secret inside our Kubernetes cluster so that our PX-Autopilot can talk to the repo. But here, the one big change in this Autopilot definition or Autopilot rule definition is that we have an enforcement where approval is required. So here, this is where before expanding the volume, it will basically wait and ask for you to accept or merge and commit the PR before it can go ahead and proceed with the storage expansion. We have similar labels and similar rule defined, like 15% of the PVC should trigger an expansion, or should trigger an alert, and then add 100% more capacity to a maximum size of 100 gigs. So let's get this going as well while we wait for the previous application to be triggered. And then we have similar Postgres instances. So Postgres wall, we'll just deploy it against the GitOps namespace, and then we'll deploy the application as well. Okay, so let's go back to our user interface like Grafana Dashboard and see. Yeah, as you can see, when it crossed the 4.5 gig mark, the 15% threshold, the rule was triggered and it automatically added or doubled the capacity of our persistent volume. So from 30 it went to 60 gigs, and my data, which is still getting written, like we had asked pgbench to write a 30 gigs worth of data for us. That's still in progress, but now our volume has more storage to accommodate all the new IO that's coming in. Let's go back and look at the same command that we were looking at earlier. So these are all the events that happened, right? So we had our a normal mode where once our persistent volume was deployed, Autopilot rule picked it up. Then it looked at the metrics and it was triggered. Then it went into an active action spending mode, and then excuse me, it actually made the necessary changes and increased the size of our persistent volume. So if we do a kubectl get pvc, get pvc and GitOps, going back to the GitOps workflow, right? We have our two PVCs similar to what we did for the auto one, and then we have our pgbench running in the GitOps namespace as well. Let's look at the logs for this GitOps instance, and let's see where that is at. Okay, so right now, as you can see that out of the 31 or 30 gigs that it wanted to write, it's at like 1.5 gig. So we still have some time, but we can go back and just select that persistent volume ID in the Grafana dashboard, so we are ready when to monitor it. So something that ends with DE8P. Right here. And then as you can see, we have 30 gigs of capacity, and right now it's just 39 megs is written. While the IO is happening, let's log back into our Portworx container and look at some commands, look at the volume status. So let me exec back into it. So here you can look at all the different volumes that are defined from a Portworx perspective. So as you can see, something like we had deployed all three PVCs as 30 gigs, but after Autopilot did its job for at least the auto namespace, that the size of that persistent volume was expanded and doubled basically to 60 gigs. We're still waiting on the first one to be or not the first one, but the GitOps one to reach the trigger point, and we look at the GitHub repo. But here you can come and look at your volume list. You can also inspect it. So again, one of the things that Michael spoke about in his presentation was the value that PX Store brings to the table, like Kubernetes native high availability, replication, encryption. All of those things can be monitored from here. So if we just copy the ID and paste it here, you can get all sorts of details around, okay, we deployed we deployed a PVC against a Portworx storage class, and in the storage class we had defined that okay, any volume that's defined needs 2 replicas, so there is some high availability. So even if one node goes down, my persistent volume and my application can still be online. So we have HA configured and we have 2 replicas. Our PXCTL utility shows us where the 2 replicas are located. So on nodes 0.4 and 0.7 is where our PVC is running, and active, it will show that okay, the pod that's attached to this PVC is running on 0.4, and that's the active node. But then if something happens to 0.4, Kubernetes will spin up a new pod, but because of our stork utility, it will deploy that pod on the 0.7 node. So there is data locality being enforced from a Portworx perspective as well. So let's go back. Let's look at the Grafana dashboard again and see if for the new application, if we reached the usage perspective. So we have our volume here, and if you look at the usage, we have out of 30 gigs, we have 5 gig that's used. So it should be in that area where the rule is triggered. So let's go back and look at that command as well. The Autopilot rule for the GitOps workflow has a different name, and that's it. So as you can see, we have from normal, the action is triggered, and then from triggered, instead of just acting on it, it is waiting for approval. So this is where if you want to use GitOps workflows and you want to maintain that single source of truth in Git, in your Git repos, you can use Autopilot to help you with that. So your current state or whatever is your active production state doesn't get drift, like there's not much drift between your active and your stored configuration. So let's go back to my GitHub repo. Again, we are using FluxCD for this. This is a simple GitHub repository. Again, you can just configure PX-Autopilot in such a way that it actually points to your application repo. Here it's just pointing to a simple Flux getting started repo that we have. As you can see, we have a PR waiting for us for approval, and we do provide you details like, okay, what's happening here. So a PVC that was 30 gigs in size, it wants to expand it to 60 gigs because our max size that we defined was 100 gig and scale percentage was 100 as well. And then it shows you, okay, what's the replica set and what's the PVC that's attached to this. So as an admin, I can approve this request and Autopilot will expand the PVC for me. But if I don't want, and if this is not something that's normal behavior, I can reject or decline this PR, and it will basically not expand the PVC, underlying PVC as well. So again, for this demo, we'll merge this PR into our repo. And as soon as we go back, you'll see that from triggered, it was waiting for approval. We did approve it, so now it's active actions pending. So this is where it basically triggers the PVC expansion for you. Let's go back to the UI and see where we are. So again, as you can see, our usage has increased. We have approved the action, so it just takes a few seconds to a minute for the PVC to actually expand. And we can see that here, like in just a couple of minutes. Like while we're waiting for the capacity to expand, let me reduce the time frame to a minute. So we are still at 30 gigs, but as we know, everything was approved. The action is in progress. It should only take a couple of a few seconds to a minute for the PVC to get expanded. Let's refresh it again. Okay, and as you can see, our 30 gig volume basically doubled in size, and now it's 60 gigs in size. So everything that we saw constitutes like a full workflow where I was able to keep writing my data, keep my application online without having to restart any pods or do any kind of manual intervention. PX Autopilot basically automates the entire workflow, and alleviates the tasks that admin has to do and makes things easier from a developer perspective as well. And everybody gets to, like, developer gets developer agility, and they get to deploy their own applications, and admins can set these policies so they can control the maximums and the triggers, but they don't have to go and manage each PVC on its own. So with that, let me see if we have any questions and hand it back to Michael.
That was awesome, Bhavin. Thank you. So we have one question so far. And so before we get to that, I'll just re-mention everybody, put your questions in the chat. We're here for you. So we want to make sure that you can kind of get all of your questions answered, whether about Autopilot or anything else, Portworx and Kubernetes related. So the first question, Bhavin, is what were you using for network?
Again, this was a GKE cluster, so whatever was default there, we don't need any specific network plugin for Autopilot to work. I can quickly check on what the CNI used was, but again, whatever is default with GKE should work.
Okay, awesome. So put your questions in. I have a question. Which would be kind of, do you have any recommendations, Bhavin, for kind of, let me start my question with a statement, which is one of the things that Autopilot helps with is kind of allowing you to under provision. So if if your user requests 100 gigabytes, but like, do they actually need 100 gigabytes of storage? Like, you have no idea as a Kubernetes administrator. And so you want to under provision, but at the same time, you don't want to maybe only get 1 gigabyte. Like, do you have any sense of, like, what would be a ballpark for under provisioning that you could apply on first blush? And then how can you kind of change that over time?
Yeah, so from what we have seen with our existing customers, right, people do see close to like 60% cost savings, and that means that we can map that back to the amount of storage that was being wasted. So if you have existing metrics on how your applications are doing, you can take that into account and under provision your storage, and then rely on Autopilot to expand your PVCs and the underlying storage nodes. But from what I've been from my experience with talking to customers, it has been like, okay, let's start with like 50% of what you actually need, and then let Autopilot expand it. So you can set a maximum threshold, but then start small and helps you save cost as well.
Yeah, and I think that what was really cool in your demo is it's kind of I always liken Autopilot a little bit to an airline that sells more airplane tickets than they have seats for, because most of the time some people don't show up, and that's every application that we write isn't going to be the one that takes over. So there always is over provisioning, but like you also don't want to back yourself into a corner if every one of the apps that is deployed does end up consuming all of its capacity. And the way I think about that is like you're at the terminal and they don't have enough seats, and so like, hey, would anybody like to spend another night in Buffalo, and to make it worth your while, like we'll give you a voucher and it's $500. And so like immediately, like they haven't even finished speaking, and you have people that are running up to the counter to take them up on the offer. So like that's how the airline gets around. Like if everybody does show up, what do we do? And it's so easy and it's so low cost that it makes the entire process workable. Well, Autopilot's the same way. It's like if everybody does show up, well, then it's just a rule. I resize my PVC, right? It takes a minute, and then now no more problem. So it's the thin provisioning is really important, but only if there's a mechanism that enables you to right size your cluster if needed. And I think your demo was a great way of showing that.
Yeah, thank you. Yeah, and as you said, right, like when you're dealing with cloud, things are elastic, so you have the flexibility to expand when needed or scale out when needed. So why not use that and leverage that even for your applications that are running on Kubernetes. You don't want to be in a state where you provision multiple EBS volumes and you're not even consuming them and you're paying for those resources. So this helps you start small, as you said.
Yeah, it's actually quite a big problem. I mean, I even know like our own infrastructure, like our test runs and things like that. Like we've written jobs to unprovision provision compute at Amazon, because it's like once you hit the button, like there is no going back. You actually have to delete that resource, even if you're not consciously using it. And the clock is ticking on the Amazon side, and you can get some kind of some nasty surprises. So I'll ask for folks for one more time if there are any questions. If so, please put them in. We're happy to answer those. If you don't have any right now, but you want to follow up with us after, you can also do that. I will, and as we're getting the last couple of questions, and I'll just reshare my screen. Can actually do I have to make myself?
Do I need to make you presenter again? Sorry.
That's good. I got it. So I'll remind folks how you can get started with everything that you've seen here today. So you can download Portworx Essentials, which is our freemium product. And you just go to portworx.com, and then I think there's a button at the top that says start for free. When you create an account, you'll be given a couple of options. One of them is for Essentials, which is our freemium offering, which does not include PX-Autopilot. But if you want to try PX-Autopilot, you can download Portworx Enterprise, which does. And so you can try all of the features, including Autopilot, and really test it out in your environment, free, full featured for 30 days. And if at that point, you want to move forward or you have questions, feel free to engage with us. And you can also download and try PX Backup from our website as well. With that, Bhavin, I think that was great. I learned a lot, and I hope our audience did as well. Thank you everyone for joining. If you think of any questions that you couldn't ask today, as soon as you hang up, then you know where to find us. Just visit us at portworx.com. There's a contact us form. You can send those over. We're happy to help. All right, everybody. Thank you.
Yeah, thank you for your time, everyone.
Bye.